Hello students, welcome back to chemistry online class. Quickly, I'm going to treat some questions, some likely questions for Jamb 2025 here, and that is on the calculation of empirical formulae and molecular formulae. In my previous video, I differentiated between empirical formulae, molecular formulae, and structural formulae. And so let's quickly look at the first question here. An hydrocarbon X has a molar mass of 26 and a carbon atom percentage of 92.3. What is its molecular formulae? Normally, when we calculate empirical formulae, from empirical formulae that we have worked out, we can get molecular formulae, provided we are given either the molecular mass of that compound or the vapor density. And if you have vapor density, you will multiply it by 2 to get the molecular mass. And if you are given molecular mass, fine, you can use it directly. And then using empirical formulae with the molecular mass, you get the molecular formulae out. So here now, we are referring to an hydrocarbon X, and we want to get the simplest ratio of that compound out. So this hydrocarbon then is made up of carbon. Since carbon percentage is 92.3, carbon, only carbon was mentioned. And from the option here, we have carbon and hydrogen. So it means an hydrocarbon here is made up of, the hydrocarbon they are referring to here is made up of only hydrogen and carbon. Some hydrocarbons are made up of carbon, hydrogen, and also oxygen, even with other elements. So in this case, we have carbon has 92.3%. That's the percentage composition. And that of the hydrogen in it is 7.7. How did I get that? I deducted 92.3 from 100. Now here we have the percentage here. And the next thing now, from the information provided, the atomic mass of carbon is 12. So we have to divide this percentage composition by the atomic mass of each element. And so in this case, 92.3 divided by 12 give us 7.67. Why 7.7 divided by 1, which is the atomic mass of hydrogen, gives 7.7. So the next thing here is to divide by the least value. Which of this is the least? I think they are approximately the same value, so almost equivalent to each other. So we divide both sides by 7.67 since it is the least, and is almost the same as 7.7. So dividing both sides, both values, we have 1 here, and here we have 1.000. So in this case, this is also approximately equals to 1. So it means that the ratio of carbon from the information provided is 1, and the ratio of hydrogen is also 1. So in other words, we have C1H1, which means CH, because the 1 there is invisible. So this is the empirical formula that shows the simplest ratio of atoms of elements in this hydrocarbon. The carbon has the simplest ratio, which is 1, and hydrogen also has simplest ratio, which is 1. Now from here we can get the molecular formula using the empirical formula, and then you put N outside. That shows the number of each atoms of elements in that compound, which we are going to work out. Once we get this N, we can use it to deduce the molecular formula. And so, thank God the molar mass was given. If you are not given molar mass, if you are given vapor density, don't forget, multiply it by 2. So in this case now, carbon, the atomic mass of carbon is 12, plus hydrogen is 1. So we had this together, while N is outside, and then we have 26. So this is 13, N equals to 26. Dividing both sides by 13, we have N as 2. So if N is 2, then we can work this out as C2, substituting 2 for the N. So we have C2H2. So this is a molecular formula, and the actual formula of the hydrocarbon, that is ethane. Why the empirical formula is CH, which shows the simplest ratio of atoms. You can see if you divide this, now you have CH, which shows the simplest ratio, and that's the empirical formula. Why this is the actual formula of a compound which exists, and this is ethane. Is the actual formula of ethane hydrocarbon. Now over to the next question. What is the state of matter in which particles are widely spaced and move freely with high kinetic energy? In kinetic theory of matter, we were taught that solids are made up of particles, liquids are made up of particles, and gases are also made up of particles. But the nature of the particles in solid, the particles are tightly held together by strong bonds, while in liquid they are held by weak bonds, and in gas the particles are free. And in this case, we also know that from the kinetic theory of matter that increase in temperature increases the kinetic energy. What's kinetic energy? The energy that is possessed by a body, a moving body, or a body in motion. So they possess kinetic energy, and this is brought about by increase in temperature. So when temperature increases, kinetic energy increases. So in solid now, it will require a very high temperature to break the bonds holding the particles before the particles can be free. And so that's why we have solids having definite shape. They can be compressed, and they have high density. While liquids flows because they are held, the particles of liquids are held by weak bonds. And in gases, the particles are free because they are held by little or no bonds or very weak bonds holding the particles together. And they possess high kinetic energy. Why? When you open a container of perfume or gas at one side of a room, and within few minutes you start perceiving the odor everywhere. Why? Because the particles are in motion, they are moving, and they have a kinetic energy, high kinetic energy. And so the best answer here is D, because we are asked to choose the one that is widely, the state of matter that is widely spaced and move freely with high kinetic energy. And we would have chosen plasma. Plasma is another state of matter anyway, but in this case now, plasma have particles that are charged, electrically charged, positive and negative particles. So the best answer here is gas. So our answer is option D. While in the first one, our answer is option A. So to get a very good score in Jamb, one of the tricks is also to, one of the method you can use is also choose carefully your answer. Check through the options properly before you choose the best answer, and keep updating yourself as well. There are some information that are outdated. Before, we know that the state of matter are solid, liquid, and gases, but we have more than 3 states of matter. And so keep practicing, keep upgrading, keep working hard, and don't forget to subscribe to my channel if you are new on this platform. Share my videos, like my videos, press notification bell to get notified if I upload new video, and I'm working more on other interesting topics as well. Subscribe to my channel if you have not done so. Thank you very much.